Hi, I'm Dion from mathsvideos.com. Now, just before I start into this question, just like to talk about the two differentiation questions that come up every year. Now, I would highly recommend doing them because differentiation gets two separate questions every single year compared to the likes of, say, logs or complex numbers, which are just thrown in at different parts. But differentiation, it's on two separate questions, and it's reasonably easy as well. So if I were you, I'd really recommend doing differentiation. Anyways, to differentiate this, we have y is equal to a term on the right hand side. So that implies dy dx is equal to 3 times the term, which is 4x squared minus 1 all to be squared times. Now it's a chain rule coming in here, but I'm going to go into more detail in the next question if you're not too sure of it. So that's times the derivative of what's in the bracket, which is 8x. That implies that 24x, or dy dx is equal to 24x times 4x squared minus 1 all to be squared. So now I'm going to do the chain rule here in this question. So now we're given that y is equal to sine the inverse of 2x divided by 3. So just for a chain rule to come into effect here, I'm just going to let u equal to 2x. That implies du dx is equal to 2. So y is equal to sine the inverse of u all over 3. Now, as I've noted up the formula here on the left hand side, the derivative of sine the inverse of x over term is equal to 1 over the square root of the term squared minus x squared. So that's equal to dy du is equal to 1 all over the square root of 3 squared minus u squared, which is 9 minus u squared. Now, don't forget we're asked to find dy dx here, and this is only dy du. So I'm just going to write this down here. Dy dx is equal to dy du times du dx. As you can see, we can just divide one term by the other, so that means dy dx is equal to dy dx. So dy dx is equal to dy du, which is what we have. 1 all over the square root 9 minus u squared, 9 minus u is equal to 2x all to be squared times du dx, which is equal to 2. That implies dy dx is equal to 2 all over the square root of 9 minus 4x squared. And that's reasonably straightforward, that question. Most of you should be getting it. The next question is differentiate root x with respect to x. On this question here, it's always better to let the term, to keep it in the square root, because if we took this out and let x equal to a half, it's actually way more complicated to do it. So we start off by leaving it like this. So that implies f of x is equal to root of x. F of x plus h is equal to square root of x plus h. F of x plus h minus f of x. I mean, these steps are pretty much straightforward for any differentiate from first principles. There's just a little kind of jigging around on the right hand side sometimes. So f of x plus h minus f of x minus f of x is equal to the square root of x plus h minus root x. Now, our next line is f of x plus h minus f of x all divided by h. That is equal to square root of x plus h minus the square root of x all over h. Now this term is actually going to be hard for us, because when we do limit tends of h to 0, we're going to have a denominator equal to 0, which means our term is going to be undefined. So what we really want to do, we want to jig this around a bit. So what we're going to do is we're going to multiply it with a conjugate of the numerator here. So we're going to multiply above and below. We're not changing it, we multiply above and below with the same thing. So we're going to multiply above and below by square root of x plus h plus root x. So that is equal to the square root of x plus h minus root x times the square root of x plus h plus root x all over h times square root of x plus h using that. That's by plus root x, so yeah, plus root x. Now we multiply this by this, we just get x plus h. And multiply this by this, we get root x times that. But then that's the opposite to minus root x times that. So that just equals 0, so I won't write that out. So basically them two terms equal 0. And then the minus root x times root x is equal to minus x. And that's all over h times root x plus h. Plus root x. Now as you can see here, that just means, well, once it cancelled, x minus x is equal to 0. So we just, there we go. That'll just make it easier for you to see. Now what we do here is, we want to get rid of our h's here, because obviously if the denominator goes to 0, then we're in trouble. So any number divided by itself is always equal to 1. So basically, you just wipe that out again. Is equal to 1. And our next line is, remember what that is now? That is f of x minus h minus x left all over h. That's the same term, so limit as h tends to 0 of this term. I won't write out the left term in brackets. Again, I said limit h tends to 0. It's equal to 1 all over, so basically this is 0, so root x plus root x. 1 all over 2 root x. And if we differentiate x to the half, just without being from first principles, that's our answer there. We can kind of tell straight away whether it's right or not. So the answer to that is 1 over 2 root x. And our next question here was, find the equation of tangent to the curve at the point 9, 3. Let's find this page here. Right, that's our slope. So we're asked to find the equation of the tangent at the point 9, 3, and whose slope is 1 over 2 root x. Well, we know if the slope is 1 over 2 root x, we have to fill in 9 as the x value. So the slope m is equal to 1 all over 2 times root 9, which is 3. So that's equal to 6. Then we just use the regular equation of the line here. Y minus y1 is equal to m to x minus x1. So y minus 3 is equal to m, which is a sixth, into x minus 9. So y is equal to 1/6 x minus 9 over 6 plus 3. But 3 is also 18 over 6. We'll just write that down as 18 over 6. So that implies the equation of tangent in the form of y equal to x plus c is y equal to 1/6 x plus 9 over 2, which is plus 3 over 2. That's the equation of the tangent at the point 9, 3.